A long pause. The night sky is a canvas of infinite wonders, a silent, sprawling expanse that has captivated us since the dawn of consciousness. Each star, a distant sun, each glimmer, a story waiting to be told across unfathomable distances. For as long as we have been human, we have looked up at the stars. Our earliest ancestors gathered under these same constellations, weaving them into myths and legends, using them to navigate the world and mark the passage of time. This shared experience connects us all, across every culture and every generation. And in that shared gaze, we have always asked the big questions. What are those points of light? How far away are they? Where did this all come from? And the most profound question of all, are we alone? We are driven by a deep, innate curiosity. It is the engine of our progress, the fundamental impulse that pushes us to explore beyond the horizon, to understand the world around us, and to seek meaning in the grand tapestry of existence. We want to know how the universe works, and our place within it. To understand the fundamental laws that govern everything from the smallest particle to the largest galaxy cluster is to understand ourselves. The cosmos is a vast, dark ocean, and for millennia, we have been standing on its shores, gazing out at the endless waves of space-time. With the advent of science, we are just beginning to dip our toes in its shores, building vessels of knowledge to sail its depths. But the more we learn, the more we realize how much we do not know. Every discovery reveals a new layer of complexity, a new set of questions. The universe doesn't just give us answers, it gives us better, deeper questions. It is an invitation to wonder, to explore, to never stop seeking. Today, we will count down 10 of the greatest mysteries that science currently faces. These are the frontiers of our understanding, the puzzles that occupy the minds of physicists, astronomers, and cosmologists around the world. We will journey from the strange to the profoundly baffling, from the nature of reality itself to the ultimate fate of everything. Each mystery is a puzzle piece, and we do not yet know how they all fit. Some may connect in unexpected ways, while others might require a complete revolution in our thinking to solve. The complete picture remains tantalizingly out of reach. Each enigma is a doorway that challenges our assumptions about the cosmos and our place in it. To step through is to leave the comfort of the known behind and venture into the thrilling uncertainty of the unknown. These questions fuel discovery, bigger telescopes, bolder theories, and more ambitious missions. They are the reason we build colossal instruments to peer deeper into space and design experiments to probe the very fabric of reality. Let us begin our countdown. Think of it as a voyage, not just through space, but through the landscape of human knowledge. This exploration will take us to the edge of space and time, from the instant of the Big Bang to the far-flung future of the universe. So, what are the biggest puzzles the universe has left for us to solve? What are the great unknowns that will define the science of the next century? The journey begins now. We begin our countdown with mystery number 10, dark matter. It's often described as the invisible scaffolding of the cosmos, a mysterious substance that provides the gravitational framework holding entire galaxies together. Without it, the magnificent structures we see across the night sky would simply fly apart. Our first clue to its existence came from observing galaxies. The stars on their outer edges spin far too fast for the gravity of the visible matter, the stars, gas, and dust, to hold them in orbit. Something unseen, something massive, must be adding the extra gravitational pull needed to keep them from being flung into the void. While we can't see dark matter directly, we can see its profound effect on space-time. Its immense gravity warps the very fabric of the universe, bending the light from distant objects behind it. This phenomenon, known as gravitational lensing, creates beautiful arcs and distortions, allowing us to map the presence of this invisible matter. It shapes the vast cosmic web, an intricate network of filaments connecting clusters of galaxies across billions of light-years. Making up about 27% of the universe's mass energy content, dark matter is the silent architect of the cosmos. So what is it? Is it a new type of particle, like a WIMP or an axion, that barely interacts with our world? Or does its presence point to a flaw in our understanding of gravity itself? The hunt continues in deep underground labs and with powerful telescopes, searching for an answer. Mystery number 9 is perhaps even more perplexing. Dark energy. It is the force responsible for the accelerating expansion of the universe. This discovery was a shock. We expected gravity to be slowing the expansion down, but observations of distant supernovae revealed the opposite. A gentle, yet relentless push is driving galaxies apart at an ever-increasing rate. This force, whatever it is, accounts for a staggering 68% of the cosmos, yet its fundamental nature remains completely unknown. Is it an intrinsic property of space itself, what Einstein called the cosmological constant? Or is it a dynamic field, dubbed quintessence, that could change over time? Or like dark matter, does it hint that our theory of gravity needs a profound revision? Mystery number 8 takes us to the very edge of existence, the beginning. Our best theories, from general relativity to quantum mechanics, describe the universe with incredible precision, but they break down at the moment of the Big Bang, at T-0. The laws of physics, as we know them, cease to apply. What, if anything, came before time began? Was our universe born from the collapse of a previous one in a big bounce? Or is it just one of many in a vast cosmic multiverse? The answers may lie hidden in the faint afterglow of creation, the cosmic microwave background. And at number 7, we encounter the ultimate abyss, an object predicted by relativity where gravity becomes absolute, the black hole. These are regions of space-time so dense that nothing, not even light, can escape their grasp. Once you cross the point of no return, the event horizon, all paths lead to the center. No information can return from beyond this boundary. Or so we thought. This creates a paradox. If information is truly lost, it violates a fundamental principle of quantum mechanics. But Stephen Hawking proposed a solution. Black holes aren't entirely black. They slowly leak a faint glow of particles, now known as Hawking radiation, which may carry information away. This leads to an even stranger idea. Is all the information about what falls into a black hole somehow encoded on its two-dimensional event horizon, like a cosmic hologram? And what lies at the very center? A point of infinite density, a singularity where our physics fails us once more. What is the true nature of a black hole's heart? We do not yet know. Mystery number 6. Time. Why does it flow one way? Entropy increases, setting an arrow. But why was the early universe so ordered? Our fundamental equations are time-symmetric. The arrow may be statistical, or deeper. Mystery number 5. Are we alone? With countless worlds, life feels inevitable. We are searching. Mars, ocean worlds, and exoplanet atmospheres. Yet the cosmic phone has not rung. The Fermi Paradox endures. Is interstellar travel too hard? Do civilizations self-destruct or hide? One alien microbe would transform biology and our place in the cosmos. Mystery number 4. The universe's constants appear exquisitely tuned for life. Tiny changes. No stars, no atoms, no us. Dark energy's value is absurdly small, yet not zero. The worst prediction in physics. Lucky draw, or the anthropic principle. We observe a life-friendly universe because we can. Perhaps a multiverse, with varied laws, and we inhabit a rare hospitable bubble. Or a deeper principle fixes the constants. We have yet to find it. To understand the cosmos, we may need to understand ourselves. Mystery number 3. Consciousness. How can matter become aware? We can map processes, but not how they produce subjective experience. Is consciousness emergent computation, or a fundamental feature of reality? Mystery number 2. The missing antimatter. Why does matter dominate? A tiny 1 in a billion excess of matter survived and formed everything. Experiments probe subtle differences in matter and antimatter behavior. Solving this may reveal a new particle or a new force. Mystery number 1. A theory of everything, uniting quantum mechanics and gravity. Our two great theories speak different mathematical languages. At singularities, both break, yielding gibberish. A deeper framework must exist. String theory, loop quantum gravity. Beautiful yet short on testable predictions. Why these laws and not others? Is there a single elegant equation behind all? Finding it would crown centuries of inquiry, the final triumph of reason. As Hawking said, it would be like knowing the mind of God. These mysteries are threads of one vast, interconnected web. Our journey through the cosmos has revealed a universe woven from threads both seen and unseen. Dark matter, the invisible scaffolding of the cosmos, and dark energy, the mysterious force accelerating its expansion, are not just footnotes in our cosmic story. They are the principal authors of its future, fundamentally tying into the universe's ultimate fate and its grand, evolving shape. These great unknowns remind us that for all we've discovered, we stand at the shore of a vast cosmic ocean. We've peered into the heart of a black hole and back to the dawn of time, finding singularities at both extremes. These points of infinite density represent the limits of our current understanding. Yet, they might be two sides of the same coin. The physics governing a black hole's core could be the very same physics that ignited the Big Bang. Understanding one singularity, therefore, may unlock the profound secrets of the other, leading us toward a unified theory of everything. Similarly, the profound imbalance between matter and antimatter points back to our first moments and hints at the existence of new physics waiting to be discovered in the echoes of creation. And what of time itself? The relentless forward march of the arrow of time may not be a fundamental property, but an emergent one, arising from the finely tuned initial conditions of our universe, a cosmic accident of unimaginable precision. It is a universe with this specific arrow of time and these particular laws that births minds capable of pondering them. We are not separate from this cosmic drama. We are a consequence of it. The path to understanding is methodical and collaborative. Science advances by observation, hypothesis, prediction, and experiment, a cycle of inquiry powered by human curiosity working together. It's a process built on rigor and honesty. Peer review and even null results are not failures. They are vital guardrails that strengthen our collective knowledge. We learn as much by ruling things out as we do by finding them. And this great endeavor is not confined to laboratories. You can join the search. Look up at the night sky. Learn about the constellations. Visit a local observatory. And even classify distant galaxies online from your own home. Talk about these profound questions with friends and family. Curiosity is a powerful and contagious tool for discovery. In a very real sense, you are part of the cosmos, and the cosmos is part of you. The iron in your blood, the calcium in your bones, all forged in the hearts of dying stars, billions of years ago. We have only just begun to read the grand story of the universe. The frontier lies ahead, not in some distant land, but out there, among the stars. Perhaps the most astonishing fact of all is that the universe is comprehensible. The laws of physics that govern the most distant galaxy are the same ones we can test here on Earth. And with them, we can predict its past and future. This search for knowledge elevates the human spirit. It leaves us humble before the sheer vastness of it all, yet audacious in our relentless inquiry. So keep looking up. Keep asking why. Never lose that profound and childlike sense of wonder. The cosmos awaits your questions. The answers may be elusive, but the search itself is the reward. The journey is, and always will be, the destination.